welcome back to this Introduction to Robotics video series. In today's video, we'll write code to use this photoresistor or light sensor to control an LED. A photoresistor is a variable resistor, meaning its resistance changes depending on how much light it's exposed to. When there's more light in the room, the resistance decreases. When there's less light in the room, the resistance increases. This in turn results in a different voltage that's read on this pin it's connected to. In our last video, we programmed a tilt ball switch, which is an example of a digital input. Digital inputs return one out of two values, high or low, which correspond to 5 volts or 0 volts, which then get translated to a value of 1 or 0. In contrast, analog inputs, like our photoresistor, will return voltages that range between 0 volts and 5 volts. This voltage then gets converted to a value between 0 and 1063 in the case of the microcontroller we are using, an Arduino Uno. Analog inputs are connected to the analog pins on our microcontroller, which are labeled A0 through A5 on one side of the board. These pins are able to convert the analog value into a digital value that our computer can understand. Let's start by building the project you see on this wiring diagram. Now that we have our circuit set up, let's write the code. A0 actually holds an integer value of the number 14 in the Arduino code, so we can create a variable using the type int. In order to read the value on an analog pin, we'll use a function called analogRead. This function takes in only one parameter, and that's the pin number, very similar to digital read. analogRead will return a value between 0 and 1063 depending on how much light the photoresistor is exposed to. Because analogRead returns a value, we have to create a new variable to hold this value. Let's do that now. Let's call the serial monitor library so that we can view the value of this light level variable on the serial monitor. So the room I'm in is not very bright, but it's also not dark, and we see a value of in the 900s being returned from light level. And if I cover my photoresistor with a black piece of paper, we'll see that the values kind of go down to the 600s. Photoresistors are calibrated differently, so you may notice a different range of values being displayed. Now let's write code to make the LED blink in proportion to how dark or light the room is. We do this by using the light level value in our delay function. Thanks for joining us for this Introduction to Robotics video series. Make sure you check out our videos on fun projects that you can do using the skills you've learned.